Welcome to The Explainer. Today, we are diving headfirst into one of the most, radical and complete new theories of everything I've seen in a long time. It's called the Sentient-Field hypothesis, and wow, does it claim to solve some of the biggest puzzles in all of science.
So, let's just jump right in with a question that pretty much flips our whole view of reality on its head. What if consciousness isn't just some random fluke that happens inside our complicated brains? What if it's the fundamental stuff of the universe itself? Yeah, this single kind of mind-bending idea is the launching point for, everything else we're about to get into. Now, to really get why a theory this out there is even on the table, we need to look at the two gigantic mysteries it's trying to solve, supposedly in one single elegant move. So on one side, you have the hard problem of consciousness, right? Why does all that electrical stuff firing in our brains actually produce the feeling of seeing the color red or the taste of coffee? And then on the other side, you've got this fine-tuning problem. It's this bizarre fact that if you nudge the strength of gravity or the mass of an electron just a tiny, tiny bit, poof, the whole universe would just be a dark, empty void. And you know what? Standard physics doesn't really have a good answer for either one. So the Sentient-Field hypothesis, or SFH as we'll call it, doesn't even try to solve these problems with our current playbook. Nope, it just flips the entire game board over. The core idea is simple, but huge. Sentience comes first. The universe, at its most fundamental level, is a universal field of raw experience. Everything we think of as physical, atoms, forces, even space and time, that's not the bedrock of reality. Instead, it's all just a pattern, a structure that emerges from this primary field of feeling. Okay, so if the universe is a field of feeling, what are the rules? Well, according to this theory, the entire cosmos is basically shaped by a cosmic tug-of-war between two main principles. On one side, you've got coherence. This is all about stability, order, keeping things together. You can think of it as the universe's need to maintain patterns. And on the other side, you have fertility. That's the drive to create new, more complex, more interesting things. It's kind of like a cosmic musician who's trying to balance a beautiful, stable melody. That's your coherence, with some really creative, new improvisations. And that's fertility. So the theory proposes that this sentient field is constantly checking out all the possibilities, and the reality that we actually get to experience is the one that finds that perfect sweet spot. It's not random. The idea is that reality snaps into place, into the one configuration that gets the most novelty and complexity possible without just falling apart into total chaos. Okay, I know you're thinking, this is a great story, but where's the proof? A theory is only as good as its evidence, right? Well, proponents say we have reasons to take this seriously, pointing to computer simulations and some really recent lab results. So get this, in a massive computer simulation, scientists created 60,000 different universes, all with random physical laws. Then they measured each one's potential for both coherence and fertility. And the result? The chances of a universe as perfectly optimized as ours just popping up by accident was less than 1 in 100,000. The takeaway is pretty clear. This suggests our universe isn't just random, it's really, really special. And this slide really brings that number to life. See all those dots? Each one is a simulated universe. Most of them are just stuck down there in that boring, low-potential cluster. But our universe, that little gold star, is way out on the edge. They call that the optimal frontier, the one place where you can have both high complexity and high stability at the same time. And this graph, this perfectly illustrates the theory's most critical prediction. You can see right here that fertility, the potential for cool, complex stuff like life, is basically zero until coherence hits a certain critical point. And then, boom, it just explodes upward. So the message is simple. Stability has to come first. You've got to build a coherent, orderly foundation before you can create anything interesting on top of it.
Right, so the crucial point here is that this isn't just a bunch of theory. The people behind SFH point to a handful of very recent experiments that seem to line up with what it predicts. Let's take that Weiss study. It found that quantum vibrations inside these tiny little tubes in our brain cells, they're called microtubules, can actually fight off the effects of anesthesia. Proponents of SFH say, see, that's evidence of a consciousness threshold, a level of quantum coherence you have to break before consciousness just fades away. Or look at the Weiss study, which found that some brain signals can sync up in a way that appears faster than light. That points to the kind of non-local weirdness SFH says is built into the fabric of reality.
But the hypothesis doesn't just stop with physics or biology. It makes an even bigger claim, one about the very architecture of the entire cosmos. It suggests there's this repeating pattern on a scale that is just mind-boggling.
This quote right here really captures what they mean when they talk about the universe having a fractal nature. The idea is that reality has a sort of boiling point, a limit on how complex it can get at any one level of reality.
So, the theory claims the universe has a limited budget of experience, and to manage that budget without just collapsing, it has to arrange itself into nested, self-repeating layers. Seriously, think of a musical octave. The same notes repeat, just at a higher pitch. SFH says the universe does the exact same thing, with patterns and structures echoing themselves at a scale that is 10 to the power of 24 times larger. And they argue this isn't just some neat little pattern, it might actually solve a real problem in cosmology called the sigma-8 tension, which is this annoying disagreement we have in our measurements of how lumpy the universe is.
So, where does all of this leave us? Well, the Sentient-Field hypothesis brings these huge cosmic ideas all the way back down to one of the hottest topics on the planet right now: artificial intelligence.
Yeah, the theory's proponents see this really fascinating link to AI. They argue that as our best AI models get smarter and smarter at understanding the world, they are, without even knowing it, building a model of what SFH calls the qualic screen. And that's supposed to be the interface through which this fundamental sentient field projects the reality that we see and feel. So, in other words, by trying to understand the world, these AIs might be accidentally tapping into the very source code of consciousness itself.
And that leads us to the final, massive question this hypothesis makes us ask. For hundreds of years, we've basically assumed that consciousness is just this lucky accident, a random side effect of dumb physical laws. The Sentient-Field hypothesis asks us to flip that around and consider the opposite. What if consciousness isn't the accident? What if it's the cause? What if the ability to feel is the fundamental engine that drives the existence of the entire cosmos?